In this video, I'll show and explain you the functional unit Connect. The question here is, how can I efficiently connect all the components of the charging station right up to the vehicle? For the other functional areas to be able to work, energy and data need to flow. Connection technology is required for this purpose and needs to fulfill different requirements. Often this technology is implemented based on various framework conditions. For example, charging stations are installed in different situations. This influences the total power required and therefore the cross-sections of the connecting cable. When connecting a single 22 kW AC home charger, 6 square millimeter is sufficient from a purely technical standpoint. In some cases, however, 60 square millimeter cables are used, either because they are already available at the installation site or in order to reduce line loss, or as a reserve for later expansions. If multiple AC charging stations are connected to one grid connection, as in multiple family buildings, parking garages, or a neighborhood, then a daisy chain design can be useful for reducing the wiring effort. Due to the number of charging points, the power requirements add up very quickly and conductors greater than 16 square millimeters are required for technical reasons. In the highest power class of DC and multi-chargers, larger cross-sections of 50 square millimeters or greater are required. Due to the high power levels, daisy chains are difficult to implement, therefore charging stations are usually connected individually. No matter what conductor cross-section is selected, the feed-in cable must always be routed into the housing of the charging station in a dry way. In large format stations, this is usually done into the housing from below through the soil. Home chargers, in contrast, hang on the wall or are mounted on a base or a column. Therefore, the cable entries are exposed to the weather. Cable glands from Phoenix Contact are a proven, robust and sealed solution for panel feed-through. They are available in many different versions. A strain relief can be integrated as an option. Manufacturers who want to make installation even more convenient for electricians can equip the housings with system connectors. Matching connectors can be provided pre-assembled for installation so that home chargers can be connected even by trained workers. Installation only needs to be approved by an electrician before commissioning. Phoenix Contact offers two product solutions: QBD connectors with quick-on connection save up to 80% of assembly time. PRC connectors with screw connection are an economical alternative. Both systems can be used up to 6 square millimeters. After its entry, the feed cable must be attached in the charging station. Here we come to one important difference in the structure of charging stations: the assembly. This can basically be done in two different ways. The advantage of DIN-rail mounting is the use of standard components that can be combined to meet the user's individual needs. This requires a manual installation, wiring work and space. In general, the technology is robust and long-lasting. In the case of maintenance, individual components can be easily exchanged. Because of this way of assembly is commonly used for public AC charging and fast charging parks, for instance. In contrast, PCB assembly, also called a single PCB solution, is becoming more and more common for high-volume home chargers. A high degree of automation is achieved in mass production, which helps to reduce costs. In addition, it is possible to build very compactly. The disadvantage is that the repairs are less economical. Often, the entire home charger needs to be replaced instead of the single defective component. Phoenix Contact offers the right connection technology for both types of assembly. If DIN-rail mounting is used, terminal blocks from the Clipline Complete program for all required cross-sections can be used. High current terminal blocks for cross-sections up to 240 square millimeters are used specifically for DC charging in the upper power range. For feed-in to the printed circuit board, PCB terminal blocks in the Combicon Power family are available. Here, the LPT family with lever connection is a fast and convenient solution for 6 and 16 square millimeter cables. After feed-in, the energy must be distributed to the electronic components within the charging station. We can differentiate between marshalling and potential distribution. In the PCB solution, both are handled directly via the conductor CHARX. This means that no further components are required. In the case of DIN rail mounting, terminal blocks from the Clip-Line Complete range are used for marshalling, either with tool-free push-in connection or in any other connection technology, such as screw connection. Plug-in bridges and versatile uniform accessories support efficient wiring. Our space-saving PT fixed distribution blocks are an excellent choice for potential distribution. They are available in different colors as well as for different cross-sections and numbers of positions for quick wiring. Communication between charging stations, users, operators and other actors is partially wired and partially wireless. Both types have their advantages and disadvantages. With a wired connection, first the data cable, usually Ethernet, must be routed into the charging station in such a way that it stays dry. The same cable glands can be used here that are also used in the feed-in. Depending on whether the cable is used pre-assembled or is individually cut to length and assembled on site, an appropriated feed-through must be provided. Data cables are not only used to connect charging stations. Also within the charging station, components are often connected to each other for data transmission. RJ45 patch cables are commonly used in this case for wired Ethernet connections, as well as coaxial cables to connect wireless LAN and mobile communication antennas. Phoenix Contact serves all these data connections and mating phases, with pre-assembled data cables individually manufactured on request, but also with single data connectors, meter goods and suitable tools for self-assembly. These components are available in a high-quality industry standard and therefore offer the needed reliability. Finally, for each data cable, an appropriate connection socket in or on the charging station is required. If the Ethernet connection of the charging station is done by a rigid installation line, this must first be connected to an RJ45 patch panel. The patch panel sits on the DIN rail and transmits the Ethernet signal to flexible patch cables, which allows a structured cabling. In addition, the integrated shield ensures reliable data transmission, which is an important aspect in commercial charging stations. Of course, our portfolio also offers RJ45 and coaxial connectors for the PCB assembly of home chargers. Service and maintenance with predictive replacements of components play an important role in commercial charging points. Maintenance connections make the service technicians' work easier by allowing a fast connection and supply of external devices. Sockets provide a power supply for technicians' devices such as laptops, even in remote locations. With the EO family, Phoenix Contact offers sockets that can be used for DIN rail mounting. A USB service interface is frequently used to upload the latest firmware or customer-specific application software to the charging station. In the case of DIN rail components, the charging controller usually already has a USB interface. In PCB-based home chargers, they are designed indirectly. Our portfolio also includes appropriate USB ports for PCB mounting. Finally, the user connects the charging station to the vehicle during operation. Different components are required to safely transmit the charging current. From the infrastructure socket to the charging cable and the vehicle inlet, we offer a wide range of solutions with CHARX Connect. These are described more detailed in the functional area Charge. Overall, Phoenix Contact offers a complete portfolio of connection technology to connect power and data to the charging station reliably and efficiently.